वेलकम टू आवर चैनल बी ऑलवेज लर्नर। आज हम इस वीडियो में फोरियर सीरीज रिप्रेजेंटेशन का सब टॉपिक, जिसमें कि हम इवेल्युएशन ऑफ फोरियर कॉफिशिएंट्स करते हैं, जिसमें हम फोरियर कॉफिशिएंट्स की वैल्यू निकालते हैं, तो वो डेरिवेशंस हम यहाँ परफॉर्म करेंगे। और आपको वीडियो पसंद आएगा, आप लाइक करिए, शेयर करिए और चैनल को सब्सक्राइब करिए। ये लास्ट एनालिसिस है जो लास्ट वीडियो में हमने किया था। So here we are having a xt signal which is represented by this one. So this is xt signal, it is represented by this one. So इस सिग्नल में हमें ans की और bns की वैल्यू निकालनी है, तो इसको हम कैरी ऑन करेंगे and we will rewrite this formula, that is xt is equal to a naught plus summation of n is equal to 1 to infinity an cos n omega naught t small t and plus bn sin n omega naught t. So that was the xt. Now इसमें जो a नॉट है, a1 है, a2 है, and up to the an and b1 b2 and bn तक जो भी कोएफिशिएंट जिसको हमने कांस्टेंट बोला था, ये सारी वैल्यूज जो हमारे पास अवेलेबल हैं, इनको हम बोलते हैं फोरियर कोएफिशिएंट्स। सो हमें इनकी वैल्यू का पता होना चाहिए। सो वी हैव टू फाइंड आउट द वैल्यूज ऑफ an, a नॉट और an. सो इन वैल्यूज को हम इसमें आइडेंटिफाई करेंगे और पता लगाएंगे। टू इवेल्युएट, फर्स्ट ऑफ ऑल वी आर गोइंग टू इवेल्युएट द वैल्यू ऑफ a नॉट, दैट इज आवर फर्स्ट एम. सो वी शैल इंटीग्रेट द above equation, that is equation number 1, both side. Equation 1, integrate both side. So that can be written because that period we have to define here. So period of integration varies from t naught comma t naught plus capital T, because we are assuming the signal is periodic with the time period of capital T. So for that we are rewriting with the integration both sides, that integration of the signal from t naught to capital T, the xt with respect to dt, that is equal to, now the rest of the portion, the a naught, because there is a naught is a constant, so we have to integrate t naught to plus dt with 1 dt, and we can also write directly here integration with respect to time, plus with the term integration the rest of the portion, that is t naught plus capital T and bracket start summation n is equal to 1 to infinity an cos of n omega naught t plus bn sin n omega naught t bracket close with respect to time we have to integrate. Fine. So we can make it like this. So we can also like this with respect to dt. Fine. So now each of the integral in the equation number 2 is 0, since the net area of the sinusoidal over the period is 0. क्योंकि हम इसमें periodic signal ले रहे हैं, तो we can write this also, the net area of sinusoids over complete period is 0. For complete period is 0. So with that comment, this term and this term is going to be 0. Fine. So we can write this integration from t naught to t plus capital T with xt dt is equal to a naught integration t naught plus t dt. So we can land it with this term here. Now we have to integrate it, so we can write integration from t naught to t naught plus capital T xt dt. The integration of 1, and after putting the limit we can have a multiplied with capital T, and we can further implies that we have to find out the value of a naught. So further we implies that the value of a naught will be equal to 1 by t integration of t naught plus t xt with respect to dt. So that is the value of Fourier coefficient named a naught. So इसकी हम वैल्यू ऐसे फाइंड आउट करेंगे. So this is the first result we are having. Fine. Second, now we have to find out the Fourier coefficients a naught, value of the Fourier coefficients a n. a naught हमने निकाल लिया, a n हम निकालेंगे. So again we have to use the equation, the first equation we have to use equation number 1. We can say the equation number 1 multiplied this equation by cos m omega naught t to simplify it, an integral, and after multiplying we have to integrate both sides. Fine. So we can write the integration t naught to t naught plus capital T xt. We have to multiply this by cos m omega naught t dt plus that is equal to, now the rest of the portion, this one I have to consider. Now a naught is another term, take it common, a naught, and integration with the same limit, multiplying with the cos m omega naught small t with respect to dt, plus, now for the summation n is equal to 1 to infinity, take common an, and integration t naught to t naught plus capital T cos of n omega naught t cos of m, that is a multiplier, and dt. That is dt, and plus with the term summation n is equal to 1 to infinity, now for bn's, integration from t naught to t naught plus t sine of n omega naught t cos of m omega naught t dt. So after doing this stuff, we are leading with this one. The first term, this one, the first term is a 0. Why it is 0? Because we are integrating for the entire period, and for the entire period this is going to be 0 as we give the comment also. Now for the rest of the period, this term, now for this term we can define this term rather the bracket term, this term. So this term is having the value 0 for m is not equal to n. If m is equal to n, then this term is having value t by 2, but it is not equal to 0. And the another term, that is sine into cos, this term is having value 0 for all value of m and n. So using this notation, I can write that integration of xt cos of m omega naught t with respect to dt where the time limit is from t naught to t naught plus capital T, that is equal to, we can write it now am t by 2. Now we can write this am, because am is a Fourier coefficient value, that is 2 by t integration from t naught to t naught plus capital T xt cos of m omega naught t dt. So that is another value, or we can write, or we can also write the an, that is 2 by t integration t naught plus capital T xt cos of n omega naught t dt. So that is another Fourier coefficient value we can have. So we are able to calculate a naught here and a n here. Now we are proceeding towards another Fourier coefficient, that is bn. bn we are going to calculate. So to write it, we are going again to write xt for your convenience, that is a naught summation n is equal to 1 to infinity an cos of n omega naught t plus bn sin n omega naught t. Right. So that is the starting point of our calculating the value of bn. Now this is equation number 3. So I am just writing equation number 3, multiply this equation by sine of m omega naught t, and after that integrate both sides. Right. So for doing this, we are again multiplying this xt by sine of m omega naught t and integrate the entire term with respect to time, where the time limit is t naught plus capital T, is equal to, again first term, a naught sine of m omega naught t dt. Again the time limit t naught to t naught plus capital T. This is the first term. Second term, summation n is equal to 1 to infinity an integration of cos n omega naught t sine of n omega naught t dt. We can put them into bracket with the time limit t naught to t naught plus capital T, plus we can write summation n is equal to 1 to infinity bn integration t naught to t naught plus capital T cos of, here we can write sine of this term, sine of n omega naught t multiplied by sine of m omega naught t, and with respect to time we have to integrate. Further, again this term is going to be 0, and this term cos into sine, this term is also 0 for all the values of m and n. This term, the last one, term is having the value 0 for m is equal to n, is not equal to n, and its value is t by 2 for m is equal to n but not equal to 0. So using this we can write that the value of this integration from t naught to t naught plus capital T xt sine of m omega naught t dt is equal to t by 2 multiplied by Bm. So value of Bm will be 2 by t integration from t naught to t naught plus capital T xt sine of m omega naught t dt. So that's how we can calculate the value of Fourier coefficient Bn, which is equal to t by t integration t naught to t naught plus capital T xt and sine of n omega naught t. We can also write in this way. So this is another Fourier coefficient we want to calculate. So we are able to calculate the value of a naught, value of an and value of bn. So these are the requirement for getting any kind of analysis. So this is the derivation. So hope you like the video, you can understand the concept, and please share it and subscribe to the channel. Do not forget to press the bell icon.